In this session, we'll have a look at the new GUI system coming out in Unity 4.6 this summer. We'll be going through a few different aspects of the UI system. We'll be looking at layout, some of the basic controls, how it integrates with animation. But let's get started with the basics of the UI system. We'll start with an empty scene. In the game object menu, there's a new item called Create UI. We'll start by creating an image. When you create an image, you'll see that the image itself is created as well as an object called canvas. In the new UI system, all UI elements have to be children of a canvas object. If we look at the canvas, we can see that it has a canvas component, and the canvas component has a render mode. The canvas can be set to either screen space, overlay, screen space camera, or world space. We're going to have a look at a few different scenes that demonstrates these different types of canvases. In this scene, we have a canvas set to screen space overlay. This is a classic choice if you want to have UI elements that are on the screen overlaid on top of the scene. In the scene view, you can see that there's a rectangle indicating where the canvas is. This corresponds to the screen, and it uses the current resolution and aspect ratio of the screen. So if we change, for example, the size of the game view in order to make the screen bigger, the canvas and its rectangle in the scene view will change its size as well. This means that you can easily work with GUI in the scene view without needing to have the game view visible at all times. In this scene, we have a canvas set to screen space camera. This is similar to screen space overlay, but we're referencing a camera that we're using to draw the canvas with. In this case, we have a camera that's set to perspective and which has a certain field of view. This means that the UI elements can have perspective. The canvas is being rendered with a camera, so all the settings in the camera are used. For example, if you change the field of view, you can control the amount of perspective distortion you want. In this other scene, we have canvases set to world space. When I click on the ground in this game, you'll see a small circle that indicates where the player is going next. This is a canvas with a graphic on it. And when I go over near to this element, you'll see a speech bubble in world space. If we look at this one, it's a canvas. We have a canvas set to world space, and under it we have an image element and text. Now that we've seen some of the different types of things the GUI system can be used for with the different canvas modes, let's have a look at how the layout system works. If you look in the toolbar, you'll see that besides the four existing tools, the hand, move, rotate and scale tools, there's a new tool that's called the rect tool. The rect tool can be used to move elements around, resize them, and rotate them all in one. The rect tool is probably familiar for anyone who's used the 2D tools in Unity, but now it can be used for both 2D, GUI elements, and even 3D objects. The rect tool uses the current pivot mode and space in the toolbar just like the other tools, but when working with UI element, you'll usually want to have it set to pivot and local. The next thing to notice is that for UI elements, there's a component called rect transform that is in the place where transform would normally be. The rect transform has position, rotation and scale just like transforms, but at the same time it also has width and height that is used to define the dimensions of the rectangle. When you use the rect tool to resize an object, normally for sprites in the 2D system and for 3D objects, it will change the local scale of the object, but when it's used with an object that has a rect transform on it, it will instead change the width and the height so that the scale is kept the same way it was. The rect transform also has the pivot built in so that you can change the pivot on the fly. Rect transforms rotates and scales around the pivot. Correction forms also have a concept called anchors. Anchors are visible as small triangles in the scene view, and they're also shown in the inspector. The anchors indicate where this element is anchored to. So in this case we have the settings button and its parent is the window. So this settings button is anchored to the center of the window rect. I'm going to use a preview way to change the window size temporarily. And we can see that when the window is resized, the anchors stays in the center of the window and the settings button follows with a fixed offset relative to these anchors. The gizmo in the inspector also shows this relationship. It currently says middle center and the graphic indicates the same thing. If I click on this, I get a drop down with anchor presets. These are commonly used options for the anchors. For example, I can set the element to be anchored to the left side. You'll notice that the button stayed exactly where it was, but now the anchor's at the left side of the parent. What happens now, if I resize the parent, is that the button stays with the left side. It's not at the left side, but it's anchored to the left side, meaning that its offset relative to the anchors at the left side stays the same regardless of the parent size. I mentioned a few times that the button keeps a fixed offset relative to the anchors. What this means is that when you define a position for a UI element, its position is relative to the anchors, and the point in the UI element that you are specifying the position for is the pivot. So the position is the pivot relative to the anchors. The drop-down with anchor presets is handy for some of the most commonly used options, but the anchors are not confined to those presets. In fact, the anchors can be anywhere you want them to be. If you click on the anchors in the scene view, you can move them to be wherever you want them to be. You could place them 0% from the left side, 50%, 100% from the left side, but it can also be at any other percentage. For example, we could place them here, that's probably around 15% from the left side. And now if we resize the parent, you can see that the anchors stay true to this percentage and the button has its fixed offset relative to those anchors. You'll see that when you've made your own placement of the anchors, the inspector will say custom because it doesn't match one of the presets defined. But anchors can do more than that. If we click on the header in this window, we can see that the anchors look different. They're split apart. One part is on the left side of the parent and one part is on the right side. If we preview resize the parent, we can see that the title stretches together with the parent. In fact, the left side of the title has a fixed offset to the left side of the parent, and the right side of the title has a fixed offset to the right side of the parent. This is called stretch in the presets, and you can set elements to stretch either on the horizontal axis or the vertical axis or both. Again, you're not restricted to the presets. You can move the anchors around exactly as you want it in the scene view. You can also split them on both axes. That corresponds to stretching both horizontally and vertically by a certain percentage. You'll notice that when you have a UI element with some amount of stretching, the inspector changes. In this case, it doesn't say position X and width. Instead, it says left and right, indicating the offsets of the left side of this element compared to the anchors on the left, and the right side compared to the anchors on the right. So those can be thought of as margins compared to the anchors. However, it's worth noticing that even though the inspector shows the values in a different way when you have stretching, the underlying logic is still the same. The elements are still defined in terms of the corners of the element itself relative to the anchors. And that's no matter if you're anchoring something to the left side or the right, or you have stretching, or anything in between. In order to show the flexibility of this anchoring system, let's try to place two buttons side by side. If we take the Continue button, let's say we want this to share its space with the button next to it. So we duplicate it, place it next to it, and now we want the buttons to keep the same offset to the sides and also keep the same gap in the middle, but otherwise stretch. So we take the anchor of the left button and take the left side of the anchor and place it all the way over to the left side of the parent. But the right side we keep in the middle because we want the right side to have a fixed offset to the middle. Similarly, for the other button, we take the right side of the anchor and move all the way over to the right side of the parent. Now, when the parent is resized, the button stretches and they each take up approximately half of the space, but keeping the correct fixed distance on the sides and in the middle. Now that we've gone through the basics of the layer, let's have a look at some of the components in the UI system. And let's start with the graphical components. The basic graphical components are image and text. So let's create an image. The image component has a few properties. There's a source image where you can specify a sprite. These are the same sprites that are also used by the 2D system in Unity. Let's assign this window sprite. You can set the color of the image. You can also specify a material if you want. The image type can be set to symbol, sliced, tiled, or filled. Symbol means that the image is simply stretched, although you can choose to preserve the aspect ratio if you want to. Sliced mean that there are certain border regions of the sprite that are kept without any stretching and only the center part is stretched. This is very useful for many UI elements. The borders are set up in the input settings of the sprite. The tiled option is similar to sliced, except that the center part is tiled instead of being stretched. The fill part has different effects we can use to fill up the sprite gradually. But we're going back to sliced. Let's create some text as well. The text has a few settings. There's a text string you want to display. There's the font style, the font size, line spacing, and you can specify whether you want to support rich text. You can also set the alignment. And if you have a long text string, then you might want to pay attention to the overflow settings. You can turn wrapping off or on. And if there's not enough room to display all the text inside the rectangle, then you can specify whether it should be truncated or overflow. The overflow setting also respects the alignment. You can also choose to say that the text should scale down in order to make a best fit. As with the image component, you can set the color and material. There's also some very bare bones settings for effects, but they're going to be very basic in version 1. The next thing to notice is the depth of the different elements. In this case, the text is drawn on top of the image. If we want to change that order, the way to do it is by dragging the elements in the hierarchy. By dragging the text element up above the image, it's now the first child, which means that it's also drawn first, and the image is drawn afterwards on top. This is similar as in Photoshop, where you drag layers around in order to determine which ones are drawn on top. Another graphical element is an image mask. If we create an empty game object and add an image mask to it, then we can mask other objects by making them children of this mask. Now the children are only drawn where this mask is. Right now the mask is also drawing its image, but if we make it only use its masking functionality without also drawing the image, it's easier to see what it's doing. Finally, let's look at some of the things you can do with materials. If you set the canvas render mode to be screen space camera and assign a camera to it, then you can use materials that use in-game lighting. For our window, we can assign a material that accepts lighting. Our image is very dark because there are no light sources, so let's try to add that. Now we have a UI element that's lit by a light source. This is just one example of what you can do with custom materials on your UI elements. We've looked at some of the graphical components of the UI system, so now let's try to look at some of the components that you can use to create interactive controls in the UI. Some of the controls you can create are buttons, toggles, sliders, scroll bars, and input fields. We'll start by making a simple button. We could choose a button from the Create UI menu, but let's try to create our own button from scratch instead this time. We use the image we already have, and then we add a button component to it. The button, like most of the other controls, have a few different sections. That's a transition setting that's used to control what you want to do for hovering effects and when the button is pressed and stuff like that. You can set it to either none, color tint, sprite swap, or you can use full-blown animation. In this case, we're just going to use color tint. This means that in play mode, the button changes to this yellow color when I hover it, and it changes to an even darker yellow color when I click it. The navigation section controls how you navigate between different controls using keyboard or a controller. This is relevant if you have more than one. So let's duplicate our button a few times. In this case, we've set navigation to automatic. You can also set it to explicit. In this case, you can select which other control should be selected when the user presses up, down, left or right on the keyboard or using their controller. But when using automatic, it will automatically find sensible choices for you. You can also visualize the connection by pressing this visualize toggle. This will show arrows in the scene view that shows the connection between different controls. For example, for the selected control, if I press down, it shows that it will go to the control below it, while if I click the right, then it will go to the control that is below and to the right, because it's a best fit for what to do when going right. Finally, perhaps the most important part of a button, what happens when you click it. Let's create a cube in our scene. Now, let's make the cube pink when you click the button. First, we add an element to the onClick list. We need to drag the cube into the slot, and then we can choose to call some function on one of the components of the cube. In this case, we want to get the mesh renderer component, and set the material. I want to set it to this pink material from the assets. Now when I go into play mode, the cube should turn pink when I click the button. And it does. Let's have a look at one more control. This time we'll create a slider and we'll use the pre-built one from the Create UI menu. Let's hook up some functionality to this slider. Let's control the field of view of the camera using the slider. For field of view, we would want the value to be between an angle of, say, 30 and 90. Now on the unvalued change list, we add an element and we drag the main camera into this slot. Now we want to find the field of view property in the camera component. Now there's two sections here, dynamic float and static parameters. If we choose the field of view under static parameters, then I can type in a value that the field of view is going to be set to whenever the slider is changed. But that's not what we want. We want the value to be controlled by whatever value the slider has. So instead we choose camera and choose field of view under dynamic float. Now the value of the slider is going to change the field of view. This works in the inspector, and of course it also works in play mode in the game, where the slider in the game can be used to change the field of view of the camera. Most of the other controls are very similar to the button and slider controls we already looked at. They have a section for transition, for navigation, and then some fields that are specific to that component, and at the end, some events that you can hook up to the control in order to make it do stuff. Lastly, let's have a look at the animation integration with the UI system. In this 3D menu scene, we have a window that's animated coming into the screen. This is simply using the animation view that can also be used to animate 3D objects. If we look at the canvas, it has an animated component, and the animation view has been used to animate the window coming into the screen. So if we go in animation mode and scrub the timeline, we can see that it has been moved. This is simply done by moving the position of the window object using the move and rotation handles, and that's the way that we can animate it. So we could add a little bit of rotation here if we wanted to, and let that be part of the animation. Another thing to notice is the animation of the buttons. We looked at the different transition modes for the button element before. This time we're going to have a look at the animation transition mode. When you choose animation, there's a button you can click to basically set up an animation controller and all the required animations needed. Then you can use the animation view and simply select the one you want to edit, and then edit it in the same way you always do with the animation window. For the normal animation that's used when the button is not being hovered, we don't have any keyframes at all. For the highlighted that is used when the mouse is over a button, we only have one key. You could have multiple keys in order to animate things, but in this case we're using only a single keyframe per animation and letting the crossfading between the animations handle the transitional effects. By switching on and off the animation mode for this animation, you can compare it to the normal state of the button. In this case, for the highlighted animation, we've changed the offset of the background, and we've also changed the color of the background. You can also see the numbers and the color change when switching in and out of animation mode. The same is the case for the other animations. Say we wanted the buttons to also become wider when they are being hovered. In this case, we choose the highlighted animation, go into animation mode, find the button that we want to make wider, and then either use the inspector or the scene view to type in the width that we want to have. This is then automatically added to the animation, and we can go out of animation mode and our work is done. Now if we test it out, we can see that the buttons now become wider when hovered. The animation transition mode is the most powerful this way because it can be used to animate as many different properties as you want. There's one last thing we want to show in relation to the animation integration in the UI system. In this scene, we have an exit button. The exit button is placed in the upper right corner, and that's regardless of what the resolution is of the game. When you click it, it changes size and goes into the center of the screen. And now it's placed in the center, and that is again regardless of the resolution. Let's have a look at what's actually going on. If we select the button, we can see that it's anchored to the top right. But when we click the button, it triggers a show animation. And that animation is animating the position of the button. So let's have a look at that. This is the show quit dialog animation that makes the button go into the center of the screen. If we go into animation mode, we can see that the button starts out in the corner. And if we select the button, we can see that it's indeed anchored to the upper right corner. However, in the end of the animation, it's anchored to the center and also placed in the center. What happens is that not only is the position animated, the anchors are animated as well. That's one of the nice properties of an anchoring system where everything is using the same underlying logic. If we'd used a system where anchoring to the right side was one mode and anchoring to the center was another, it would not have been possible to interpolate between these different states. But because everything is just floating point numbers that can be interpolated, you can make transitions between any layout you want. Creating these animations are not hard either. Let's say that after the button has gone down to the center, we want it to proceed up to the left right corner and stay there, regardless of the resolution. So we find the time where we want this to happen, we move the object to where we want it to be, and we set the anchors to where we want it to be. We could move it here, or we could just set it using the anchor presets. Now the object moves from corner to center to the other corner, and this works regardless of what the resolution is. That's it for now. There's a lot more to tell about the new GUI system, and we're going to do that over the coming weeks and months. We hope you enjoyed this overview, and thanks for your time.